Uh, when recording, and I will start give a briefly introduction at the beginning, and I will let you know when you can start. Yeah. Okay. So hi guys, this is Chris from DoraHacks, and glad to see you guys again. Today we are very pleasure to have Carson Farmer, who are working in Filecoin R&D Textile. He will be introducing us the Filecoin Bridge permission storage for your dapp, DAO, or NFT with us today. And before he starts, please let me briefly introduce the background of this workshop. Right now, DoraHacks and the Polygon are co-hosting the Polygon-Grants hackathon, which is the very first global Polygon-centric hackathon, but also the first Polygon quadratic funding grants, where we were all using Matic token as the main voting and donation currency. We're really looking forward to all the amazing new projects building on the Polygon network. So without further ado, let's welcome Carson to start his workshop. And remember, guys, if you have any questions during the session, feel free to ask in the YouTube and Bilibili chat room. And thanks for joining us today, Carson. Feel free to start when you're ready.
Great, thanks a lot, and good day to everyone out there, or good morning, or good afternoon, wherever you may be. I am not sitting in on that YouTube Slack or YouTube discussion right now, so I will try to jump on there after the session and answer any questions that come up along the way. In the meantime, let's get started. So yeah, I'm here to talk about this Filecoin bridge that Textile has been working on, that is bridging storage to Filecoin across multiple blockchains, and in particular today we're talking about Polygon. So pretty excited about this. It's a new project, and I think you're going to like it. And it looks like the questions are going to be passed on to me too, so that's great. So first, just a little bit about Textile in case you aren't familiar with us. So we are, like most tech startups in this space, we're pretty mission driven, and in particular, our mission is to accelerate the exchange of information across society. And we think that keeping humanity's data safe means creating systems that promote the exchange of data and information across borders and through time. That's the sort of blurb we like to give everybody. And I think it encompasses a lot of the things that are important to humanity at this moment. Right now, we're doubling down on Filecoin as the means to safeguard humanity's data. And so we're really committed to getting as many bytes as possible on the Filecoin network, because we think this is the most direct path to getting everybody and every organization and every community to actually own and control and preserve their data, over the long term. And so the way we approach development and bridges that I'm going to talk about today is no different, is that we build products as experiments to test assumptions about Filecoin and any of the other protocols that we're working with, as well as the assumptions around how users will use it and how the network will operate. And so we tried to do this out in the open as much as possible. And we basically use each product that we've developed. And if you're familiar with Textile, you might have heard of some of our past things that we've worked on and current things that we work on, like threads and buckets and Powergate. So these are all projects and products that we work on out in the open to gather new data and then sort of leapfrog along to the next project. And so today I wanted to talk to you about one of these projects, as I mentioned, Bridges, which is turning out to be a pretty powerful open protocol or concept for providing permissionless storage to blockchain users, and in particular Polygon, in the native token. And so that's kind of a pretty important piece of that puzzle. And I'll talk a little bit more about what I mean by that as we go along. So just want to make sure everybody can still see my screen there.
Yep.
Yeah, good. So yes, what are we talking about here? Bridges. We call this thing Bridges, and Bridges essentially make it possible for developers and their users to start storing data on Filecoin as long as they.
Carson, yeah.
Yes.
Just want to make sure. So what is your screen looks like? Is it like the blue slides PPT or?
Yeah, it
You
should
are,
be a blue side that says bridges on it.
yeah. That's cool. I thought you are trying to sharing something else. Yeah.
No, we're still there so far. Just good. I don't see the red line, so I wasn't sure. Anyway, there we go. Right. Lost us our train of thought there. But anyway, so yeah, what are bridges? Bridges are really about bridging native chains, so Polygon, to Filecoin blockchain. And so really all you need to use a bridge to store data on Filecoin is a blockchain address. So you can start storing data on Filecoin from just about any blockchain that we've sort of got our hands on. And you don't need to make any like conversions or token exchanges or signups or developer tokens or secrets or anything like that. Really just a native blockchain address or account. And so for those of you who aren't familiar with Filecoin, although probably not many given the topic of this hackathon, Filecoin brings a lot of the best parts of the IPFS stack. So that's like verifiable data, peer-to-peer data exchange, deduplication, and all that stuff. They bring that in an incentivized blockchain space. And so the idea here is that we can actually create a lot more powerful and an unstoppable data storage layer for decentralized apps and their users by directly bridging those dapps to Filecoin. So that's the sort of high-level idea. And so we're building a Filecoin bridge just about every blockchain that we can get our hands on. As I mentioned, we started on Near, and now we've done Ethereum and, of course, Polygon, with some more to come. And really, bridges are just an open interface for providing Filecoin storage to blockchain apps. So under the hood, it's really, they can use any mechanism under the hood to actually do the storage on Filecoin. Though we do have some best practice systems that are already running in production for actually doing that. But really, it's just a set of off and on-chain communication interfaces. So when using the bridge, users or a dapp or even a smart contract, they still, add data like they normally would. So you upload a file, and they still can retrieve that data using its content ID, just like on IPFS, like they normally would. But the raw data itself is also going to be available in storage contracts created with miners or data storage providers on the Filecoin network. And then the metadata for that storage can then be reported back on chain to the native chain as open and reusable building blocks for referencing in other, smart contracts or things like that. And I'll talk a little bit more about that in a sec. But the core Filecoin storage bridge basically revolves around two key concepts: deposits and storage. And I've sort of tried to highlight them here in this figure. So the deposits API, that all happens on chain, so on Polygon. And then the storage API, it actually interacts with off-chain, what we call a validator. So an off-chain storage validator. And that's the node that actually interfaces with Filecoin. And so validators handle things like compiling data, batching it into larger batches, and then making deals with the Filecoin network. And then they also are responsible for reporting deal success back to the native chain. And so the validators are down here, and dapps can interface. Once they've interacted with the on-chain component, they can interface directly with the off-chain validator to push data to Filecoin. And so what this means is that basically users can interact with the contract. They set a deposit. I'll talk about that in a second. And then they push data to the validator. And along the way, the data is actually cached in a highly available IPFS layer while the validator is doing all of the hard work of sealing and proving and things like that on Filecoin. So users get sort of like fast, immediate feedback, and they can interact with that data. They could add that CID as metadata to an NFT, or they can, reference that in some sort of on-chain event while the data is making its way to the incentivized storage layer that is Filecoin. So then validators do a bunch of other awesome things, like they provide CID indexing and a bunch of other like on-chain events later on, so that, for instance, you could have a node that is sitting listening to events that are being emitted by the on-chain contract for any new deposits or any new Filecoin storage, and then kick off some sort of, operation or some sort of interaction to reflect that. So the way that works is the on-chain piece is for leaving a deposit. So leaving a deposit, so the dapp leaves a deposit either on behalf of the user or has the user, sign a transaction and leave a deposit with the contract. This basically provides a degree of Sybil resistance, so that users who want to store data on Filecoin via the validator, they first deposit with the validator's on-chain contract, and they deposit some funds proportional to the length of time that they'd like to open a storage session with the validator. So right now that's about 0.00036 matic per hour. That works out to be about 100 quai per second. And you can open up a storage session and start storing data with the validator. After the funds expire, whoever deposited the funds or anyone really can release those funds back to the depositing party that was interacting with that contract. And so, anybody can release the funds. So they don't get locked up in the contract during the long Filecoin proof process. They really only need to be in there during the storage session. And once the deposit is available, then the app user can start pushing data to the validator at their stated endpoint. And there's a on-chain contract, or there's an on-chain method to get that as well. So the off-chain storage part, where you're pushing data to the validator, that's a REST API, basically. Just takes some file bytes for upload, and then sends the bytes off for preparation on Filecoin. It also has a status API, so you can check to see the status of the deals at any time. And those status or stati range from anywhere from batching to preparing to deal making right up to success when it's actually on Filecoin. And so along the way, clients can sort of just ask the validator, hey, where's my data? What's the status? So this gives a really, if you're developing a dapp and you want to provide Filecoin, archiving to your users, the status API gives a nice way to sort of reflect that in a UI. You might have, red, green, blue lights or something like that. So it's a pretty, useful API. So I thought, given the audience here, it might be a little fun to dig a little bit more into the on-chain components, just because that's probably what people are interested in. So we as I mentioned, there's sort of like two components, and then the on-chain components are separated into two main contracts. And so there is a registry, and then there are multiple on-chain validator contracts. So if you look here, there could be n is unknown. There could be as many validators as we want. And then there's generally one registry, although there could be multiple registries if the community really wanted that. But in general, one registry, multiple registered validators. And so the registry is really just like a logically centralized registry of validator contracts. And it's just a very simple interface. And in practical terms, it looks like this Solidity contract here. So it's ownable and upgradable and all that stuff. And there's really just two events: when a provider is added and when a provider is removed. This is using some of the older language that we were using, so you can just kind of swap provider for validator. And then three APIs: add, list, and remove. Add and remove can only be called by the owner of the contract. So really the only thing that anyone is going to want to interact with is list providers. And so this just gets back a list of the registered providers, and then you can use whatever mechanisms you want to filter on that list and choose a provider. Random is probably fine at this stage. The contract can be transferred. So this could actually be like operated by a DAO or something like that. And so in the next phase of our development, we'll actually be defining how we're going to develop governance around adding and removing validators to the registry. So it could be some sort of like DAO or multi-sig setup where there's a sort of voting before a provider is added or removed, to provide a little bit more decentralization to that contract. So that's pretty exciting. The second sort of on-chain component that's interesting to look at is the validator contracts. And these are similarly pretty simple. That's the whole contract definition right there. Can be implemented by anyone who wants to run a bridge validator node. And so that's what the core interface looks like over here. It doesn't have to be sort of upgradable or ownable, because really it's up to whoever's deploying this contract to decide on that stuff. But because they'll be under the control of whoever's running the validator. But the interface is pretty lightweight, and this is easy to fork the existing one and deploy your own. And really, it only needs to support a few basic APIs. So it needs to have an API endpoint parameter, and then add deposit, has deposit, and release deposit. And then there's a helper method, release deposits, which will just go and release everybody's deposits. Probably clients aren't going to want to call that, because you could be paying for gas to release someone else's deposit. Who wants to do that? So chances are you're just going to release deposit for your own. And then there are pretty much just two events, add and release deposits. There are additional events, which we haven't sort of formalized yet, around on-chain reporting. And that would be like that, the Filecoin deal success and a few other events like that. And these events are kind of important because you can use the graph or some other mechanism to listen for those events and then index them. And so we've got that working already, and we're working with the graph on some other chains to actually then have indexing of Filecoin deals on Polygon and on or via the graph for all these different blockchains. So this is pretty cool thing, because it means you get sort of like a third party to query and monitor the operation of the on-chain components. And that's a pretty important thing when we're talking about decentralization. So yeah, we can dig into this contract more if anyone is interested, but I think we probably have time to do some demo and examples and stuff if I keep moving along. So I will try to do that. How do you use these contracts and interact with them? There's a couple of ways. If you're a smart contract developer, you could make cross-contract calls and deposit some funds from your dapp for your user or users. So you can just do a direct cross-contract call. You can listen to these events, as I mentioned, and start reacting to on-chain activity. So maybe you're running like an indexer node or something like that. As I mentioned, we've already started integration with the graph for indexing these contracts. So you can actually build dapps or even just full-blown sort of web apps that monitor Filecoin storage requests, for instance. But if smart contracts aren't your thing, we also provide a pretty much zero config TypeScript JavaScript SDK that sort of wraps this whole bridge system up. That makes it pretty easy to store data on Filecoin from any blockchain-based dapp. So if you're developing, an Ethers.js app, or you're interacting with MetaMask, then this will feel pretty much right at home. And I'll go through some code snippets and things for people who are interested. So like I said, this should, the SDK should feel pretty comfortable if you're familiar with common, ETH, Polygon, JavaScript libraries like Ether.js. And so it ends up being a pretty small API. It's really just sort of deposit, release, store, status. And it integrates really nicely with your existing ETH Polygon development best practices. So if you already have a JavaScript or TypeScript dapp where you're interfacing with a wallet, then you've already got like 99% of what you need to get to integrate the SDK. Really, all you need to do is just import the library, have your user or the dapp that you're calling it from deposit some funds, and then you just start uploading files. You can even just hook up the upload endpoint to a form submit in your React app or whatever you want. It's quite simple. And so what I thought I would do is we can actually go through a really quick demo where I've already made a React app, and we can kind of explore what that looks like. And then I'll break down just the core code snippets that we actually need to make all that magic stuff happen. And then I'll try to do a live deployment where we'll grab some code, we'll deploy it, and see if we can interact with MetaMask and upload some hello world example. And we'll do it live so you can see how easy it is. So first things first, I've got on the slide here, there's a bunch of examples and docs and things that you can check out. And so I'll try to make these slides available at the end, but there's a couple of basic sites that you can check out. So eth.storage is the main doc site for the JavaScript or for the bridge system. And you can check that out. And then I'm going to actually go through and show you a demo that's also available in this GitHub repo. So let's see if I just open up eth.storage and go here. Oh, I opened up the wrong. Let's just copy and paste it. Looks like I've got the link a bit funny there. Yeah, we'll just do this. .storage. There we go. Okay. So if you go to eth.storage, you'll see this lovely web page, very basic. I go in there and read about it and learn a little bit. We do have a JavaScript page that's got some demos and examples, and there's some updates coming to provide even more context code and examples. But if you get on the main page, you can kind of scroll down to this ease of use section. And there's a link to a live dapp that you can sort of play around with. So if you click on that, and we have demos for ETH and Polygon and Near. So we'll click on this ETH and Polygon one. And, it's not the prettiest dapp because it's just a quick little example. So, best practice isn't really to pop up a MetaMask signing thing upon loading a page, but you get the idea. So this is popping up my MetaMask thing, and I've already set it up so that I have a testing account here. So I'm going to hit sign to allow this. And it just dumps you on this very basic page here for our demo. There's my testing public account. And right now I'm connected to Polygon Mumbai. And so that's where the demo is deployed, or that's where my account is set up, and I'll interact on that blockchain. But we support Rinkeby, Polygon, mainnet as well as Near. But anyway, so the whole idea here is we've kind of just basically created buttons that reflect the APIs that are available. So I can start by just clicking deposit, and it'll pop up a MetaMask notification that says, hey, do you want to deposit enough funds for about an hour? I will confirm that. Yes, please. Excellent. And then I can just upload a file. So I always end up using this one, which is pretty cool. So I'll open that. There we go. Confirmed transaction 14. And then upload, probably should have called this store because that's the name of the API on the SDK, but we can click upload. And then this is basically pushing data to a remote validator node that Textile is running. And then it spits back the IPFS CID just to show me, okay, this is actually up, it's on IPFS. So you can interact with that using that CID. And it pops it down here too. I could copy that CID. And before I do that, I can also check the status. And so if I hit status here, it pops up and it says, okay, the deal status here is batching. So that means that the remote validator node has this data, and now they're basically like going to include this small file in a larger batch that will then get pushed to a Filecoin in a Filecoin deal. But in the meantime, I can, say copy that CID, open up another tab, and let's see. I think I've already checked this earlier today. Yeah. So that's just a public IPFS gateway, and the data is available there as well. So you can use the CID or hash, in a contract or anywhere else, and access it over the normal public IPFS network, all the while it's being stored on Filecoin. So that's pretty fun. And that's the basic demo. And the cool thing about this basic demo is I actually used it the other day because I was sort of playing around and I wanted to mint an NFT. And so I wanted to have the asset be an IPFS hash. And so I actually just used this basic demo and I uploaded the asset that I wanted to mint. And then I just got a reference to the CID and I used that when I actually minted my my NFT. So it's kind of like a handy just file uploader to IPFS/Filecoin. And so it's sort of inspired. I might spend a little time and we might clean it up a bit and make it a thing, but it turns out to be kind of handy. But anyway, without breaking, now I don't want to go into that React app because it's full of Reacty things. And really the most interesting bits are only about less than 30 lines of code. And so I thought I would just pull this up, which is a much simplified version of this this app, or the part that's interacting with the bridge. And so if you look over here, we've got a couple lines of code here. So I'm going to use Ethers.js to interact with MetaMask or whatever my Web3 provider happens to be. In this case, it's MetaMask. In theory, this should also work with Web3.js, though that's a little untested. I know some folks have played around with it. So, proceed with caution, but in theory, that should work as well. And this is, basically the lines of code that you need to make this work. We've got a way to sort of request to sign in. So that's basically like pulls up the initial MetaMask, pop up and says, do you want to let this dapp access your MetaMask? You click sign and you're good to go. Then you get a reference to your Web3 provider. This is standard boilerplate for pretty much every dapp that you might wish to create. You can interact with your wallet by grabbing the signer there. You get a signer object, and then that's what you pass into the initialization function for ETH storage. So just pass it in it with the wallet, and you'll get back a storage object. And this is a really basic API wrapper that has a deposit, release deposit, has deposit, store, and status endpoints. And that's pretty much it. There's a few other things in there that sort of handy dandy things, but other than that, that's it. And so then, in my case, I uploaded a file in that last demo and sent the bytes to there. But really all you need is a file object to send. So, drag and drop interaction or whatever, or you can just create one sort of manually yourself. So in this case, I'm creating a new blob that says hello world. It's just plain text. I wrap that in a file object, say that it was last modified just now, create a file, and then I'm ready to go with that file. Then what I do is I just call storage.addDeposit. And if I don't give it any arguments, it'll just use the default of my account for 1 hour. I can also specify that I want to leave a deposit for someone else's account. That's no problem. It's going to be, I'm going to fund it, but I'm basically going to say hey, I want you to open up a session for, 0x blah, 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 blah for an hour, but I'll pay for it. So that's how dapps can fund storage on behalf or leave deposits on behalf of their users. But by default, it'll use the calling account. And then you can also specify how much. And as I said, by default, it's an hour. You can leave it for much longer. You can do it for much shorter amount of time. It's really up to you how long you want to leave it, how much of a deposit you want to leave. and it's a linear function of time. So the bigger the deposit, the longer the storage session. Now I should mention, and I think I'm going to, I think I have a slide that alludes to this, but I should mention that right now, you'll get your whole deposit back. So the storage on the bridges is subsidized. And so that means it's basically Filecoin storage for everybody is free via the bridges. This is thanks to funding from Filecoin and from Polygon. So you can thank the Polygon ecosystem for that, as well as there's some incentives that are keeping Filecoin storage really cheap right now. So Filecoin itself is like basically free. And then any of the gas fees and things like that come out of all these interactions on Polygon, very minimal, but any one of those that are happening are being covered. So thank you, Polygon and Filecoin, for those grants. And yeah, I mean, for those of you who are thinking of playing around with this, there's like zero, it's basically free storage for you and your dapp users. So why not? And the default right now is for a full year. So basically you can store something provably and permanently for free for a year. So do it. Anyway, once you've left that deposit, you can then store the file, and that's just storage.store file. And you'll get back a response that includes the storage ID and the content ID for the file, CID in this case. We are working to improve some things so that really the only thing you need is the CID. And then you can like query based on that later, say, hey, what's the status of this CID? Tell me all the deals that this CID is in. And in theory, you could also query the graph to say, for a given user, what CIDs have they stored? And so that's pretty cool, because then you can start doing things like, having a dapp that allows users to upload files, and then they can actually like query and generate collections of files and things like that later, all using basically on-chain interactions and referencing off-chain data. So that's pretty cool. So that's the storage API. And then we don't need that. And then you can check the status later. And so that's what that's going on. And so that's what all those calls were doing. And so I've still got a little bit of time left. So I thought what we might do is a quick little demo. And so this is something that everybody can do at home if they want to play around. And so I encourage you to do so if you feel sort of gung-ho. There is actually a live, so this is a link to some data that I pushed to, or a script that I added to IPFS. And so you can click on it and it's over here, and I'll run that in a second. But I just wanted to show you how I did that. So I showed you some sort of code snippet, and I showed you the React demo. Now I want to show you just like how simple this really is. You could just write a script very quickly that integrates all of this stuff super easily. So I am going to just create a teeny tiny like modern JS web page kind of thing using ES modules and deploy a fully functioning app. And I do use that term very loosely. But anyway, we can do it here. So, you'd start by making a new directory, and you move into that directory. And then you could just like initialize an NPM module in there if you so wish. In theory, you don't need to do that even, but for the purposes of sort of ease of install and stuff like that. If you're using Deno or something else, you can do that as well. But anyway, we'll initialize NPM init. You go through a bunch of prompts to say, you want to build an app. Oh, that's cool. What are you going to call it? Blah, blah, blah. And then when that's done, you just install a few things. And really, the only things you need to install to run, like the runtime things, there's two libraries: Ethers.js, which you're going to need anyway, and then Textile's ETH storage. That's it. And then I'm also including this very fast ES module bundler and a little tiny HTTP server so that I could serve it up. But even for this demo, I don't even need that. I really only just need this as a dev tool. So then what I would do is I would create my little module.js file. and I would create my index.html file. And then I just run ES build, and I bundle it up, and I pump it to a file called out.js. And if you do that with the file I'm about to show you, you end up with something about yay big. I think we could do better if we really wanted, but this is a teeny tiny demo, so I think that's sufficient. And this is the entirety of the script that we're going to run. So it's a self-running async function with 2 imports up at the top and a couple of like just, here's this. This is actually, you probably shouldn't do it this way. You should use the more modern ways of enabling your Web3 provider, but this one's nice and succinct, so I left it. So await window.ethereum.enable. Grab the provider like we did before, grab the signer like we did before, create the storage object, create some data, add the deposit. And then I just have a couple things here because I knew that I would run this demo after I had already left a deposit. So I have a really basic, just like catch that just passes through and ignores the error. But if you try to deposit on top of another deposit, it will return an error, which you could then just like handle. And so I'm just not handling it. So just a little pass through here, no op. Then we'll just wait a few seconds because otherwise the whole thing goes too fast and it's not very interesting. And then I'll store a file, print out the IPFS gateway link, and then check the status, which should be batching because it's the first time I've uploaded it. That's the whole entirety of the script. Here's the whole entirety of the web page that I'm going to create. Just references my out.js. And then I could just fire up a little tiny HTTP server and serve that. Or I could just host it on IPFS. IPFS add, blah, blah, blah. You could probably also actually upload this via a bridge, which would be sort of mind-blowing. And I just thought of that now. I probably should have done that. But anyway, you get the picture. It's very decentralized. And so we could go to this URL and check it out. And so I'm going to do that. So this is just like a script, that HTML file plus the code that I showed you that I deployed to IPFS. And if I run it, again, this is like a pretty like bare bones like app. So it's not exactly like coding best practices, but it should. I probably didn't actually add it to IPFS. Add it to IPFS yet. So let me do that. Over here. There we go. Excellent. Or actually, I will just do just to be on the safe side. Live demos being what they are, I'll run it locally. There we go. Okay, so it pops up my signature request. I'll just sign that. And now everything is just console login. So I'll just open up my console here. This is just that error that got skipped because I already deposited some funds. Here is the HTTP IPFS API that it console logs. Here is the validator and it's batching the data as I was expecting. If I click on this, it should take me to a file that says hello world. Cool. So in a teeny tiny ESM script that I deployed to IPFS, maybe if I run this now, it will work. Let's see if I can. See if I can do it this way. Open up the IPFS is misbehaving for me today. That's okay. Anyway, you get the idea. So we deployed that little web app, and we can reference the data, and it's doing all of this stuff in about 30 lines of code. So I think that's pretty much it from me. I hope you get a picture of how easy it is to use these bridges. Really just a couple extra lines to your dapp, and you can upload data directly on behalf of your users to Filecoin for long-term storage and free. So just again, thanks to Polygon and Filecoin for funding that work. You should go out and use it. As Textile is always hiring, so any devs out there who are interested in this kind of stuff, please don't hesitate to reach out. You can tweet at us, you can email at us, you can Discord at us. We're all around. And thanks very much.
Thank you very much, Carson, for this amazing workshop. Now, let me check about some questions. Okay.
Oh, good news is IPFS CID just finally popped up.
Yeah. You know, when you open a Zoom meeting, sometimes it's just loading slower than regular. Yeah. So actually, I have some personal questions for you. So, because I'm kind of like trying to get involved in some like NFT stuff, and you know, because it's a hot topic obviously right now, and I doing some research and find that so for NFT there are like two kinds of way for the storage. One is like Filecoin and SIA. It's like storage for, how to say, it's more like on-demand storage. And there's another way, which is like Arweave. It's more like long-term storage. So do you think there's like a good or bad between like all pros and cons for this two ways in comparison, or do you think in the future that it's gonna be like a mixture?
Yeah, I mean that's a great question. So as you mentioned, there are a lot of sort of quote unquote decentralized storage, incentivized decentralized storage solutions. SIA, Arweave, Filecoin, and some others even. And each one takes a sort of slightly different approach to how the incentivization structure works. Filecoin is still like a contract-based storage solution, right? So similar to AWS, where you sort of pay a monthly fee and you get storage on AWS. With Filecoin, you pay a miner a certain amount, and you get a certain amount of storage for a certain amount of time. Versus things like Arweave, which is like sort of permanent storage, where you pay a one-time fee and that thing is just stored forever. So it really depends on like your use case. If you're only going to store like a few things, but you want them forever, then maybe Arweave is an interesting approach. But it does cost a lot more because you're basically storing something forever. And because that data is stored like, you know, basically with a bunch of nodes, partial bits of that data are stored forever as sort of reference on the blockchain. But if you're storing like maybe smaller bits of data for shorter periods of time, like you're backing up a database, well, database backups from 5 years ago are probably not going to be very important anymore, because like they've changed so much. So you maybe don't want necessarily to store that forever. And also that's going to be much higher volume data. For NFTs, you know, it could go either way. It kind of depends on how you want to be able to reference it. Do you want to be able to like move that storage to someone else later? Do you think the storage costs will change over time? All of these things are going to come into play. But I think what we're going to see is over the next 5, 10, 15, 20, 50 years, we're going to see some winning and losing models emerge. And Maybe Filecoin will stick around, maybe Arweave will stick around, maybe they'll all stick around. But I think right now it's just a matter of like trying what gives you a good developer experience. I mean, to be honest, if you're not using like IPFS or Filecoin or Arweave or these things, and you are minting NFTs, you're kind of doing those people who are eventually going to buy your NFTs a disservice, because they should at least be in some content addressable format to ensure longevity. And you see a lot of NFTs that are still just stored on Google Cloud or something like that, and those links can change and can break. At least with content addressable storage, you have a CID, you have a permanent sort of like reference. So whatever you do, it should be something like that. And I don't know, I'm always a little bit skeptical when I hear something like permanent storage, because like, what is storage going to look like in 100 years from now? Certainly not like what we're talking about now. So things evolve. Anyway, that's my take, I think.
Yeah. Thank you very much for answering that. And maybe something not that technically, what is your what is Filecoin's next big move? Like are they planning something exciting? Or the free bridge with Polygon is absolutely amazing. And there like something else like that coming?
Well, I can't speak so much to the Filecoin team per se. I think that, what the Filecoin ecosystem itself is pretty amazing. And we're starting to get at the pace where it's moving at leaps and bounds now, which is pretty exciting. I think what you're going to see from Filecoin ecosystem now is just like increasing improvements in the user experience. I think you're going to see a bigger diversity of miners. Like by diversity, I mean like across, like globally in terms of infrastructure and all that stuff. So that's really great, because that means people get a lot more storage options. If you need to say, hey, I need to store this in a HIPAA compliant way, there'll be a Filecoin data storage provider that can do that. And there'll be, every geographic region that you want. So I think a lot of that is happening. I think a lot of improvements on user experience in DevX. As for the Textile team and bridges and what's next, we're thinking a lot about scaling storage over IPFS, or over Filecoin. So for instance, the bridges, concept, that's really about like, when I'm creating a dapp, I'm often creating like small bits of one-off data for my user, right? They're uploading an avatar, or they're like creating a blog post, or they're posting a tweet. So that's small data. And Filecoin miners, they want big data. They want like 32 gig sectors. And so what the bridges is about basically scaling that process and saying like, okay, give me a bunch of small data. I'm going to batch that up into something that looks attractive to a Filecoin storage provider, and then I'm going to ship that off to them. And so it's sort of like scaling that whole data storage, that whole side of the equation, the sort of data producer side of it. So I think we're going to spend more time working on that and improving the user experience there, to the point where like my like vision for this is I don't want to think about storage, right? Like I don't want to have to think, oh, I will upload this file for my NFT. I just want to say like add to NFT, or like, store this, and it's just going to be there stored with some data provider somewhere, and I can reference it by CID, and that's it. It should be sort of indistinguishable from magic. So that's where I think we're headed.
Great. That sounds pretty exciting. Not exciting, but interesting. With storage, but not storage. Some sort of things like that. It's just like easier.
Little science fiction-y sounding, but yeah, I think we're getting very close. We're so close now to, with chains like Polygon, where like I can basically have my whole backend on chain. The only piece now that's missing, like I have user authentication, right? Like I have MetaMask and different identity solutions. I have my backend system, which is my smart contract. The only thing from the sort of like web app world that's missing is backend storage. And with bridges and all the work that's happening in Filecoin, we're like so close to that too, that we're almost at the point where we can just fully like have actually serverless apps where they're literally running on the blockchain and everything is like sort of interfaced across bridges. We're so close. In the next couple of years, like you are not going to have to run a backend web server anymore.
Wow.
And that's I think that's exciting. So that's why I hope that gets people excited and just to start imagining that and thinking about that when you're building your next hack is like, can I do this so that like literally no, I need to run no backend infrastructure. And of course, always thinking about like, is this fully decentralized? No. Okay, then do I need to trust the thing that's like the centralized endpoint? If I don't need to trust them, if it's a trustless sort of relationship, then maybe it's okay that it's a little bit centralized. But if I can't trust them, then I probably want it to be decentralized. And so that's why I like the bridge system. Right now, Textile is the one that's running the main validators, but we want people to get involved in governance. We want people to run other validators so that we aren't the only ones, so that isn't a centralized point of failure. So I actually should mention that, yeah, if you're at all interested in like smart contract on-chain governance type things, please join our governance calls. I didn't put a link to them, but you can tweet at us if you're interested in that kind of thing. You should totally get involved.
Absolutely. Yeah. I mean, that's at least sounds exciting to me. Yeah. And definitely looking forward when they came true. Well, I guess that will be it for today because I don't see more questions coming up. Really want to thank you, Carson, for this amazing workshop. I believe it has been super helpful for all the audience and whatever developers who want to like try to build their own dapp or their own NFT or whatever they want to do in the future. And definitely, guys, remember to check out their Textile's Twitter, join the Discord, and like hang out with them if you have something in your mind and want to connect with them. Definitely do that. And tomorrow we will have our very last workshops with Polygon series. Tomorrow we will have Jeff Bennett, who are the balancer integration team, who are working in the balancer integration team, and talking about guide to building applications on the top of the balancer V2. And if you haven't followed us on YouTube and Bilibili, make sure you do that, so you won't miss out anything like today's or tomorrow's events. And I do hope you do great in the future of building on Polygon-Grants hackathon. And yeah, that'll be it for today. And good luck with everything. And thanks again, Carson, for joining us and present such an amazing workshop. Thank you very much.
Thanks, everyone.
Yeah. Thank you and have a good one.